Now we can make estimates of the values of the sine and the cosine function by going back to our unit circle, assuming that the radius is 1. And we can estimate our angles, theta, our x-coordinates, and our y-coordinates. For example, let's just start with the y-coordinates, which are pretty easy to see here. For this angle, it looks like the y-coordinate is about 1/3 of 1. Okay, radius being 1. So this seems to be about 1/3 of the radius. So let's just estimate that y is about, well, we'll just estimate 0.3 there. Okay, we're just going to do a rough estimate. We could estimate better if we had a really accurately drawn graph, but with the limits of the accuracy of this graph, actually when I do this, this looks like a little more than 1/3, so I'm going to call that 0.35. Okay, then this one appears to be about 0.65, and let me make one little correction here. Of course, our first point was here where the y-coordinate was 0, so I want to include that 0. Okay, this is about 0.35. This looks to be about 0.65, around 2/3 of this distance. This I'm estimating to be about 0.85, and this one I'm estimating to be about 0.95. Again, assuming this is 1, then distance up to here is 0.95, etc. Okay, now I could go around the circle and make decreasing estimates here, and then they would decrease through negative numbers here and come back up. So I could complete the estimates around the cycle, just illustrating the process. Our x-coordinates, for this, it looks like our x is probably about 0.9. Well, actually, we include the first one, the x-coordinate of the first point, which is on the x-axis, is 1. Down here, it looks like it's down to about 0.9. Here, it looks like it's down to about, pretty close to 0.8. Here, I'm estimating it looks like about 0.65, and here about 0.3. Now, those are just kind of honest estimates. And actually, that 6.5 looks more like a 6, so we'll just go there. Okay. Now, I'll observe at this point that if I sketch, I can aim the thing correctly. Okay, if I can sketch a line segment, a radial segment from the center out to one of these points, then that distance is 1, that being the radius. The x-coordinate and the y-coordinate are the lengths of the legs of either of the two triangles that I form here, the triangle here or the triangle here, so that x squared plus y squared should equal 1. So, question mark, does x squared plus y squared equal 1? Well, certainly for the first point where x is 1 and y is 0, that's the case. For the second, 0.9 squared is 0.81. 0.35 squared is actually 0.125. So that really adds up to .935, not quite 1. So that's not a great estimate. 0.8 squared is 0.64. 0.6 squared would be 0.36. 0.65 squared is going to be more like 0.43 or something. And if I add those up, I get maybe 1.07. If I add these up, 0.6 squared is 0.3. 0.85 squared is actually somewhat bigger. That's pretty close to 1.1. And 0.3 and 0.95 that's going to give me 0.09, and that's going to give me about 0.9. That's going to be pretty close. That's about 0.98 or 99. Okay, so all these squares add up to something that's pretty close to 1, and since these come from eyeball estimates on a not precisely scaled graph, these results aren't too bad. So these are reasonable results for the x and the y. Okay, what are our theta values? Well, theta, remember, is your arc length. And what are the arc lengths here? Well, the arc around the entire circle is 2 pi. The arc from here up to here is 1/4 of that, pi over 4, 2 pi over 4, pi over 2, which is about 1.57. We've divided that into about 5 segments. Let's say that from here out to here is maybe about 1.6, and if you divide that by 5, you get 0.32. So if I did that accurately, my angles would be 0.32. Sorry, that angle would be 0. Okay, so our angles would be 0, 0.32, 0.64, 0.96, 1.3, the angles here, assuming these are equally spaced. Now, this spacing is bigger than this spacing, so I didn't do a real good job of making these points uniformly spaced, but these again are just ballpark estimates. What about theta in degrees? Well, we could measure the degrees. It looks like I've divided 90 degrees, maybe a little more than 90 degrees, into 5 equal parts. That would give us 18 degrees for each. Since we've got a few extra degrees here, we could maybe say we are at 19-degree increments, so 19 and 38, 57, 76. Something's wrong there. 5 into 90. Let me think about that for a minute. It certainly is. 5 into 90 is 18. So what am I doing wrong here? Okay, I'm at least being consistent. I forgot to write down the 0 here, so my numbers didn't line up. And I was going to end up over 90 degrees when I got down to here, and that wasn't possible. Okay, so anyhow, there are a set of estimates. Now you can run these into your calculator. You can put your calculator in degree mode and see what the sine and cosine of 19 degrees are. Remember, x is going to correspond to the cosine, y is going to correspond to the sine. If your calculator's in degree mode, well, what's the cosine of 19 degrees, 38, 57, 76 degrees? And what are the sines of these angles? They should match the y-coordinates. Okay, now you can see how accurate or inaccurate my estimates were. Now you put your calculator in degree mode or in radian mode. If you're calculating for degrees, you would use degree mode. If you're calculating for radians, you would use radian mode. You should do it both ways and see how close these values are to the values of the cosine and the sine function. Remember that x is the cosine. So x value should be the cosine of theta. Y values should be the sine of theta. Okay, check the actual values with the estimates. And then do better than I did. Draw your own circle, subdivide it, make your own estimates, and compare. One thing I would recommend is subdividing each quadrant right in the middle, and then subdivide each of those and subdivide each of those. See, breaking each quadrant into 8 equal spaces, it's easier to subdivide, to divide an arc in half than it is to try to keep your points equally spaced as you move around the arc. Now, I find that these estimates are mostly good to within plus or minus 0.05. That's not great. With a carefully drawn diagram, a picture, you could do much better. But this helps you familiarize yourself with the entire circular model and gives you something to relate to. Also, this plus or minus 0.05 is pretty well consistent with the errors we see here, which are usually plus or minus 0.1. And won't go into detail how the errors combine, but there's a pretty good amount of consistency in the level of error made here and the level made here, the level of certainty. I'll also mention that since these were calculated, the correspondences between the radians here and the angles and degrees are pretty close, usually within plus or minus a few percent.